All right, now let's talk about string waves. String waves are actually fairly straightforward. For the only waves we're dealing with are those that, let's see, we start with some length of string L. All right, so we always have the length of string L. Now, each end of our string is going to be fixed, so there's a node at each end. Now, if I were to pluck this, then I would have a waveform that looks something like this. Okay, we're talking about standing waves here. So in this case, I see that the length is equal to 1/2 of a wavelength. Therefore, the wavelength of the wave produced by this wave is twice the length of the string. All right, my next choice is, what if I have a waveform that looks like this, where I have one node in the middle, one on either end, and two antinodes. Then the length of the string is actually equal to one wavelength. So the wavelength, oops, lost my pen, is equal to L. Now this is kind of cool. Watch what happens here. Now my diagram is terrible, I know. Now what do we have? Now I have the length of the string is 3/2 of a wavelength. There's one wavelength here and another half here. And that tells me the wavelength is 2 lambda over 3. Do you see a pattern here? See, this is the same thing as 2 over 2L. Oh goodness, I need an L here. Goodness, must be late. I'm starting to make mistakes. Lambda is 2/3 L. So we see that we wind up with, over here, I have L is equal to n lambda over 2, or lambda is 2L divided by n, where n is 1, 2, 3, 4, etc. So let's try a couple problems. A stretched fixed string at both ends is 2 meters long. What three wavelengths will produce standing waves on the string? All right. Well, the first one just looks like this. All right, here's my string, and then here's my wave. So L is 1/2 of a wavelength, and that tells me lambda is 2L, or 2 times 2, or 4 meters. Let's see, the next wavelength will be like this. All right. So that the length is 2 lambda over 2. So count the number of nodes, 1, 2. Here the number of nodes is 1. Here it's 2. So lambda is equal to L, or 2 meters. The third one, 1, 2, 3. Excuse me. Put my equal nodal line, and then I'll complete it out. This is what my standing wave looks like. So here, n is 3. So L is 3 lambda over 2. And that tells me that lambda is 2/3 L. So this is 2/3, and L is 2 meters. So lambda is 4/3, or 1.33 meters. Now, name at least one wavelength that would not produce a standing wave. Well, what if lambda is 5 meters? Well, what happens? Then nothing will ever be longer than your fundamental wavelength here. So if I ask you this question, anything longer than your fundamental, or anything between any of the two, lambdas won't work. So if I gave you 3 meters, that wouldn't work either. All right.